Okay, time to learn some RAG, Retrieval Augmented Generation. We're going to write some Python code. We're going to use LangChain. We're going to use Ollama. We're going to use Llama3 model, and we're going to use ChromaDB. So what we're going to do here is we're going to create a Flask API endpoint where you can actually make a call and send in a prompt into Ollama, into Llama3, a general AI request, and it will respond with that. We're going to run Ollama locally with the Llama3 model loaded locally. If you want to run on a server, you can look at my other video about setting it up on AWS with an EC2 instance with GPU support. That makes it significantly faster. And after we get our basic API going, we're going to add another API endpoint to upload a PDF document. We can upload one or more PDF documents, and then those will get stored into a ChromaDB. Once we have that done, we'll have another endpoint that we can post a query to, and it will actually query against our document then. So it'll go through, try to answer the questions of the document, and respond. Now, the cool thing about this, the way it's set up, is you can have multiple PDF documents uploaded, and based on the PDF documents, it'll go through all of them and return the information for the content as well as the sources of which one it used. So, hope you enjoy this. It's a Python course. It's a little different than the normal Java that I do. I'll be doing a Java equivalent once LangChain Java library gets there. ChromaDB is pretty much there. A couple pieces here and there need to be there. We're really, really close. I've been doing a lot of work with Vertex AI. Looks really good. Their Java libraries are rock solid. But this is with Ollama, and everything looks really good. Hope you enjoy it. The code will be in GitHub. I'll include the link to that in the comments. But it's rock solid, and I've been using this for quite some time. Hope you enjoy the video. Please like and subscribe. Thank you. First thing we're going to do today is start by getting Ollama up and running. And we can go to the Ollama website and install that. So we can go to ollama.com/download, and we can download this for our computer. In my case, it's a Mac. So I already have this installed. Additionally, we can go to ollama.com/models, and we can see the various models available. So we have Llama3, Gemma, Llama2, etc. And we're going to work with Llama3 today. And we can see the announcement that came out a couple days ago about Llama3 being available. And we're going to take advantage of all these new features and run with this. So to start with, I've already installed Llama on my computer. I am actually going to go through and run Ollama pull Llama3, and that will go through and actually download this LLM locally to my computer. Now we can do an Ollama list, and we can see that our model is now installed. Great. So we should be able to actually do an Ollama run. I can do a serve to set this up as a server. This way we can get an output of what's going on. I'm going to open up another window here. And now I'm going to do an Ollama run Llama3. And we can see from our server that I'm connecting to it, and I can ask some basic questions. Why is the sky blue? And I can see it's going through and doing all the normal connections and all that stuff. I'm going to go ahead and stop this output. Type by. Okay. So now we'll actually use curl to do a post. And what we're going to do is send it here to our local host /API/generate. We're going to pass in -D, so this will be the body of the post, and it's going to send in model Llama3 prompt, tell me a joke. Then we're going to set the stream to false. That way it'll go and get the results and won't slowly bring it back. It'll bring it back quickly. So this should all be set up here. And if our server's set up, everything should be set up properly. Okay, so here's one. Why don't scientists trust atoms? Because they make up everything. There we go. So we got our HTTP request working here as we expect. And now that I can do that, we should be all set up. Let's go through and create some Python code. I'm going to reduce our server, put the server one in the background. We're going to create a new project in my desktop directory. I'm going to call this RAG because that's what we're going for here. So I'm creating a RAG directory. And this is going to be some Python 3 code. So I need a Python 3 virtual environment. So I'm going to type Python 3 -m venv space venv. And it's going to create a virtual environment for me. Now we can see I have a venv folder in here. I'm then going to activate this. I'm on a Mac. A Windows Activate would be a little bit different. And notice I have this venv right here in the front of the prompt. So now I'm all set up, and we can start writing our first application. And I'm going to actually create a file called app.py. And I'm just going to say hello. And in this app.py, I'm going to do a Python 3 and make sure I say hello. Great. So our basic environment set up. So I'm now going to hop over into VS Code, and I'll do a code space dot, and this will open us up in VS Code. Great. Here's our project in VS Code. We can open this, and we're off and running. So let's adjust some windows a little bit here and there. And I think we're ready to go here. Okay, so what we want to do now is we're going to be using the LangChain libraries. So we're going to import this, and then we're going to create an LLM reference using Llama3, and then we're going to invoke this. And we'll ask why the sky's blue. How about tell me a cat joke? Okay, there we go. So we need to import our community LangChain. So let's go back to our text over here. And I'm going to do a pip3 install our LangChain. Okay. So it's no longer a warning over here. We have everything. Now let's try to actually run this again. I'm going to do a Python 3 app.py. So it's doing something, but we got no response. So we need to actually get a response back from our LLM call, and then we can print the response. I did another video on setting up Ollama on an EC2 instance with a GPU. That's a much faster solution. So if you want a larger LLM and a faster GPU, take a look at that. And that's a great way to set it up. That's what I do. Okay, and we see our cat joke in here. Why did the cat join a band? Because he wanted to be the percussionist. All right, so now we have our Ollama set up with LangChain, and we're using Llama3. So let's kind of take a next step here, and let's make this a Flask application. So the first thing we're going to do is do a pip install, pip3 install Flask, and it will install a whole bunch of stuff, much more than what we actually need, but that's okay. So it's telling me here that I can upgrade pip, and I will go ahead and do that. All right, that way I won't get that warning again. So now we have Flask installed, and what we can do is go ahead and import Flask so we can actually use them. I'm going to import him at the top from Flask, import Flask. All right, there we go. And there's a couple of things we can do to use Flask. We need to set up. In general, we need to define a app variable, and we'll do an app equals Flask under name. Okay, and then from there we kind of need to do something with the app stuff, and eventually, sooner or later, probably towards the bottom of our application, we're going to say if name under name equals under main, we're going to do something, and we're going to say start app. And then in start app, I'm going to simply say app.run. I'm going to say host equals 0.0.0.0. This is different than just using localhost, because what this will actually do is set up to listen on all Ethernet adapters. I'm going to set the port, and I want the port to listen to be on 8080. And I'm going to go ahead and set the debug to true. Okay. All right. Fix this typo here. Great. So now, if we go through and I say, fix that typo, start app, and I can just say Python 3 app, and it will start this as a Flask app. So first thing it's actually doing is making that call. I should go through and comment that out. Here's fix this typo here for the host equals, and then let's comment out these other items here. For now, we don't need that yet. There we go. And let's make sure we can run this. Okay. And it says don't use for production, etc., but we're listening on port 8080. Okay, so I will stop that. We'll go back over here. Now we can add some endpoints. So technically, what we're going to want to do is add a post endpoint, and we're going to want to post the value of our query. So that will be the first thing we do here. We'll go through and create a post endpoint, and we'll use @route, and we're going to call this AI. Okay, and we're going to make this methods that we support post. Okay. All right. So this will get called, and we'll define this as AI post. And then in here, we'll have some code. I'm just going to say print post AI called. There we go. So that's a start. We're going to want to do something in here, and then eventually we're going to want to respond. One of the things that we're going to want to do in here is get the value of things. So we typically post the content, we can get the request that's sent in. So we'll have to go up to our Flask and say import Flask and request. So at the end of this line, we'll add request. And this will allow us to get attributes for a specific request. Okay, in our post request, I can connect up here and get our JSON from the request.json. And then once I have that, we can say our query is from our JSON content.get. We can say query. And we should now be able to print out our query value. Okay, so this should be our query. And now that we have that, we can respond with something. In a minute, we're going to call the LLM and then return the response. For the response, we're going to return our response answer. And we need to create that response answer. So response answer for now is going to be sample response. So let's see if we can get this working. Theoretically, we can make a post to this AI and it will pass in the query and we'll get back sample response and what the query was. Okay, let's see if this works. Let's go ahead and run this now. Looks good. And we're going to bring up Postman. Okay, so we're going to do a post. This is going to be to localhost. Port 8080. And this is just going to be AI. And we're going to post a body. And this body is going to be a JSON body. And this is going to have a payload of query. And the query is going to be, told me a cat joke. There we go. Let's see if this goes through. Okay. Sample response, query, tell me a cat joke. Over here, yep, we got the query, tell me a cat joke. Great. So let's see if we can take the next step and let's make this LLM a global. I'm going to call that a cached LLM for now. And then what we'll do is we'll call our response and we'll print our response. And this is now a cached LLM. And we should be able to quickly go through with this response and set up this as a JSON object. And this is going to be answer. And it'll just be the response. Okay, let's see if this actually worked. So this is going to call using our cache LLM, tell me a cat joke, but nope, I actually want to send the query in here. There we go. So let's restart this. Let's go back to our Postman. And let's try this. Tell me a cat joke. Why did the cat join a band? Because it wanted to be a percussionist. There we go, a cat joke. How about tell me a dad joke? Here's one. Why did the scarecrow win an award? because he was outstanding in his field. All right, so now we've actually set up an API, and we're calling this by an API. So that's the first step, and we have Flask set up. On our next section, we'll dive in and see if we can take the next steps to do more of a RAG type approach. Okay, so now that we can chat with our Ollama, and we have a basic Flask API, we need to do something interesting, and let's create the capability to upload a PDF. So the first thing I'm going to go is go into our project directory. I'm going to create a folder called PDF. There we go. And then I'm going to create a route which allows me to post a PDF document and then store it in that directory. So I'm going to create a directory called PDF. I'm going to upload a file from a post, and I will get that file name, and I will save it into a path. So let's see if that works. Let's go to Postman. Okay, so in Postman, I have a file, and this file is from Alice in Wonderland. It's called Alice PDF. So let's run our application, and then in Postman, we will actually go through and post this file. It says successfully uploaded. Let's stop our server, and let's go into our PDF directory, and we can see it's there. There we go. Okay, so now that we have the PDF document being uploaded, we need to actually create a couple things, and we need to do some embeddings, and we need to parse the document that we're going to put in here. So we're going to add in a couple packages from LangChain. One of them here is recursive text splitter. So that's the first one. Second one is going to be some embeddings, and we're going to use a fast embeddings. There we go. We're going to upload this document, and in doing so, we're going to do some processing on it. We will need to have a text splitter and some embeddings. So let's go create our embeddings up here by where we do our cache, and this will be used multiple places, and we're going to use fast embeddings. There's several different embeddings that we could use, and then we also need to create a text splitter. In the text splitter, we have various options that we can pass in for that, but in general, what we're going to do is specify the chunk size, overlap, and all that stuff. So it has some values that we need to set for the chunking, and I'm going to say a chunk size of 1024, an overlap of 80 bytes, and we're going to use a standard length for the length function, and no special regex. So that's going to be our text splitter. Then we're going to take this document and we need to do something with it. We need to create what's called a loader, and I'm going to use a PDF loader. My preference is something called a PDF plumber, and there's several of them out there that technically you could use. So I'm going to add in PDF plumber, again from LangChain, and what we're going to do is in our upload, we're going to go through and use our PDF plumber against that saved file. So we create a loader. Now that we have a loader, I'm going to take that and split it using the docs. Load and split. It'll create docs for me. So now that we have the documents, let's just print out some size information. Okay, now that we have our document loaded, we can break this up into chunks. And now that we have chunks, we can print out the information on the chunks, just like we did the length of the document. And then we can get a folder path, and I'm going to create a folder path. This is going to be for the ChromaDB. So I'm just going to go up on top and define this. And again, this is just going to be DB. So we'll go over here in our text window, and I'll make a directory called DB. There we go. And that's where our ChromaDB is going to be created. So we have our chunks. We're now going to put everything in a vector store. And we're using ChromaDB for the vector store. So we need to import in ChromaDB. And again, that comes from LangChain. We do have an error here for the LangChain text splitters, and we do need to install that. So I will do a pip3 install on that. Okay, so we should now have this LangChain text splitter in here. And now that we have the vector store, we have our folder path, which is DB. For the persistent directory, the embeddings, we're using the fast embeddings, and then the document chunks we have are here from the text splitter. We should be pretty much okay. One thing that we do need to do is after we put this in there, we need to make sure it gets written out. And so in our vector store, we're going to call persist. Okay, so theoretically, if everything's good, we're going to say status successfully uploaded. We're going to put the file name, but let's also put in here a couple of other pieces of information. Let's put in here the document length. So doc length. And we're just going to put in here the length of the docs. And it should be colon in here. And then let's also add in here chunk length. I'm just going to call it chunks. Okay, so we have the file name, the length of the data, length of the chunks. Theoretically, we should be able to restart this. Let's try to run Python 3 again on this, and let's see how everything is. Looks like we have an import error for the recursive character text splitter. Looks like there may be a problem. Looks like there's a problem with how I imported this. There we go. So let me import it properly, and I think we should be okay to go now. Let's try this again. Doesn't like our fast embeddings. Let's see what we're doing wrong here. Looks like there's a package that needs to be installed called fast embed. So let's go install this. Okay, looks like that's done. Let's try running this again. So when it first starts up, it goes through and it creates some stuff for the model embeds and everything. So that's done. That only needs to be done one time, I believe. And let's try our Postman and see if we can upload a document. Okay, did not find PDF Plumber, so we need to import that. So we'll do a pip3 install PDF Plumber. All right, let's start this up again, and let's try to upload this document. Okay, getting there. It's looking for ChromaDB. So let's go through and import. Let's go through and install ChromaDB. So after we get all this put together, we'll load everything into a requirements file, and then we can do a pip install from the requirements file, and it'll have all the dependencies and all the versions that we need. Okay, once again, let's run this, and let's see what we get. Okay, so now we can see that the document is 80 pages, which is correct. It got broken up into 205 chunks. The file name is Llama3 PDF, and it was successfully uploaded. So we now have this document in our ChromaDB. So theoretically, now we can ask questions about this document. So to do this, we need to set up a different endpoint. I will copy this post, and I'll call this right here ask_PDF. Ask PDF post. And then similar to before, we'll send in a query for this. And we're not going to invoke the LLM. We're going to do a little bit additional work here. So one of the first things we need to do is we need to go and get that vector store again. So to start with, we'll need to load our vector store. Here we go. So we're using the same folder path that we were, and then the same embeddings that we were. So now we have to create what's called a retriever. This is all part of creating a chain in LangChain. So let's look at what is needed to create this retriever. The retriever will use a vector store. This is a ChromaDB. And we're going to do a similarity score threshold. We're going to get a response K20 as 20 items. And I'm going to call this a 0.1 from 0 to 1. And so that's what this retriever is going to do. Now that we have that retriever, I'm going to create a document chain. And in this document chain, I'm going to use a create stuff documents chain. I'm going to be passing in the model. And so in this case, the model is going to be what we've used before. So we use our cache LLM model. And then we need to send in the raw prompt. So in a minute, we'll have to create that prompt. But let's go ahead and let's add in this stuff chain in here. And that's going to be a import that we need to get from LangChain. Okay. And I think we may have to import this. Okay, we need to make sure that we have everything updated and installed. So I'll install LangChain Community and LangChain. All right, looks like we have that. So now that we can create this stuff document chain, let's go look at the parameters of it. And we need to send in a raw prompt, create a retriever chain, and then we should be able to get a response based off that chain. So we need to find create retrieval chain, make sure he's included in here. We'll add this in from LangChain. Now I think the last thing we need to add in here is the raw prompt. Let's see, I think we need our results in here. And let's see what we have for raw prompt. And we'll create a raw prompt outside of everything. Raw prompt. And it's going to be a prompt template from a template. And we'll make sure we have prompt template in here. It's imported from LangChain. All right. And what we want to have in here is we're going to use 3 quotes. 1, 2, 3, 1, 2, 3. And this way we can spread things across multiple lines. So we're going to tell it from the system perspective that we're going to give it some instructions. You are a technical assistant, good at searching documents. Okay. You do not have an answer from the provided information, say so. Okay. And then we'll close off our instruction. And then we'll give it a little more information here. And we're going to say, give it some information here for input. And then finish that there. We're also going to put in the context. And the context is going to be the content from the database. And the last item will be is the answer. Okay. We'll do that for our prompt. And let's go down and see how this works. We send in the raw prompt. We have the query as the input. Query as input. Yep, we look good here. All right, let's give this a run and let's see what happens. We're back to running our Python app. That looks good. So theoretically, we've put a document in here. We have a /ask PDF, and we're looking for a query. And this is going to be about the document we uploaded. So let's go through and see how a RAG works. So in this case, we have a post. We have a JSON body. And we're going to ask something about this document. Who is Alice? Make sense? And the URL is ask/Alice. Sorry, ask/PDF. So we've opened the database. We're searching to find content. We've created the chain. Once we have the data, we'll send that into the LLM for it to determine the proper answer. Okay, we got an error here that we can't just return this document. Not a problem. We need to make a couple little changes here. The first thing is, let's see what's actually in that. We don't want to return result. I think we actually want result answer. All right, let's give this a shot now. And we can also print out results so we can actually see what is in there, because there might be some more interesting stuff in there. We'll print that out as well. Okay, let's restart this guy. And we'll go to our Postman. And let's try this again. Eventually we'll find out who is Alice. All right, look at this. Answer. Who is Alice? A delightful excerpt from Lewis Carroll's classic tale, Alice's Adventure in Wonderland. In this chapter, Alice is called as a witness in a trial taking place in a fantastical courtroom. There we go, and that's the answer. So this looks like exactly what we want. But it would be nice if we knew a little bit about this. So I'm going to go through and let's add a little bit more details in here. I don't want just the answer. I'd also like to know the sources. So let's add sources. And what we can do is in here, we get this result. And I think we printed the result out. We had all sorts of information in here. And we get the answer. But in addition, we get the title, the file path, the page, and the source. So I think some of this information might be of interest to us. And let's see if we can add some of the stuff in there. So for this, what we need to do is loop through this results. And I'm going to go through and create a source. It's an empty array, source says. And then what we're going to do is we're just going to loop through the sources here. And I'm going to grab the doc meta source. And in this case, I'll also grab the page content and we'll stick it in here. And now let's go through and run this one more time. So we have our answer, but it's always nice to know how we got that answer. So we're adding in the metadata and the page content. Again, if you want it significantly faster, take a look at what I've done on my AWS setting up Ollama with a GPU. It's significantly faster. I'm running it locally on my MacBook Pro. It's an Intel-based system without a GPU, so there's no GPU acceleration. With GPU acceleration for ChromaDB and Ollama, it's 40, 80 times faster. Much more viable. If you're running this on a private network and you need to have data that's not populated and pushed out to anyone else, having a private LLM with a private RAG solution with a local ChromaDB works great. ChromaDB by default, I believe, uses SQLite to store information in, and you can set up your own ChromaDB server. I have it running within my own Python environment when it starts, but it can be set up as a server as well. By default, my Ollama is connecting to localhost, but I could actually put up a host and a port in there and have it connect to my server instance, which I typically do when I'm running this on AWS. There we go. So now we have some content information for sources, the document it came from, the reference to what it got. Again, document references, so this is pretty nice. All right, there you go. All the source code is on my GitHub. GitHub is Thomas Jay. RAG is the URL, that's project name, and it's a public repository. You should be able to see all the information in here. There is a requirements.txt. You can just run install requirements.txt to load everything, and it should have all the requirements in there. I will slowly go through and add up some more notes on the README file, but hope you enjoyed this. It is a full end-to-end RAG application using Llama3, LangChain, a Flask API, and ChromaDB. Hope you enjoyed it. You can look at the source code. It's on my GitHub. I've included the link in the description. Please like my video and continue to follow my channel. Once all these elements exist in Java, I'll be publishing the same functionality in Java. Thank you very much.